Okay, everybody, so let's work on our first hands-on project during this course, tflite, the professional course. I'm going to share my screen here, so the idea is that we are going to work together throughout this project. So first, let's recap what is our goal here. The goal is to convert a machine learning model to TensorFlow Lite and then embed that model in Android. That model should be capable of classifying images of dogs. So our final Android application should enable the user to select an image and figure out what's the breed of the dog in that image. So it's very simple and a very practical problem to solve here. So first, as you can see here at my screen, we have the development tools we're going to use during this project. These are the tools: TensorFlow version 2, TensorFlow datasets, Matplotlib, Python 3, and Android Studio. Also, this project is organized in two parts. During the first part, we use Python to convert the model to tflite, and during the second part, you take that model and embed the model in an Android application. So these are the two parts of this project. And during the first part, we use this environment here called Colab by Google. For those not familiar with Colab, it is a web environment for Python development. And basically, it allows us to develop any Python application or to run any Python script without the need of installing or downloading any additional tool in our local machine. So basically, it's an environment you can create via Google Drive, just like a Word document or an Excel table using Google. Okay, so it's a very interesting tool. Okay, so let's get started. First, we need to install the dependencies in our virtual machine here provided by Colab. So here in this first cell, we install TensorFlow and TensorFlow datasets. I'm going to run this cell here. The other libraries, the other tools, Matplotlib and Python 3 are already installed by default in this virtual machine. So I already have these tools installed, but of course, when you guys run this script here, which is shared with this video as well, you're going to install those tools. And once we have those tools installed, we need to set up the input pipeline of our model. So let me explain it better. The idea is to convert a model to tflite, but first we need to have that model. We have two options here. The first one is to have access to some model already trained, maybe online or asking for a friend, for instance. And the second option is to train a model from scratch. That's what we are going to do here. It's a very simple process. We are going to use Keras, which is a high-level framework powered by TensorFlow. So it'll be simple, and then once you have that model, we can use tflite to convert it and embed it in Android. So first, before training the model, we need to define the dataset for training. In this case here, we use TensorFlow datasets library to download the Stanford Dogs dataset. So that's what you do here. First, in this cell, we import TensorFlow datasets, and Matplotlib. So here we use TFDS, TensorFlow dataset library, to load the dataset we use, which is Stanford Dogs. We have access to the training data, training testing actually, all of the data, as well as the information regarding the data of this dataset. And we split the dataset into two partitions, the training partition, testing partition. And finally, we plot some sample images from that dataset. Okay, so here you have the output of the cell. As you can see, these are the sample images from the Stanford Dogs dataset. we can see there's a lot of different dogs in different light conditions, different scenarios. So there's a nice variety of data here, which is very good for our project. Okay, so once we have the data set, we need to preprocess its samples in order to make sure they are adequate to our model during training. So during this preprocess step, we are gonna perform two transformations on each of the images from the data set. The first transformation is rescaling those images. So we make sure their pixels are values between 0 and 1, which can help our model converging faster during training. And finally, we also resize the images so we can make sure they have all the same shape, which is necessary to train our model. Okay, so we define this method here, which performs these operations for each sample, and this method here, prepare, which given an input dataset, it applies that preprocessed method for each of its samples by calling this method map provided by TensorFlow Dataset API. After mapping those samples, we shuffle the dataset so we can make sure there is no bias regarding how those samples are arranged. And next, we group those samples in batches of size 32. And finally, we apply this feature here called prefetch, which is provided again by TensorFlow Dataset API. And basically, it allows our model to start in training, even though there may be some samples still being preprocessed. So essentially, that feature allows our model to overlap those pipelines, so the model can start running while there's some samples still being preprocessed, so we can improve the performance of training. Okay, so once you have those methods, we just need to call the prepare method here, the prepare function, for the training data and test data, and then we have our batches ready to be used during training.